This is extreme meteorologist Reed Timmer, and in this video, I'm going to break down exactly where I expect the tornadoes to happen. Good afternoon, everybody. In this video, I'm going to describe the tornado threat that's going to come together today across eastern Arkansas, central and northern Louisiana, and a large part of Mississippi. This tornado that you see here is totally different than the ones that are going to happen later on today. This was a morning tornado near Clinton, Mississippi. It wasn't the same target area as I expect the tornadoes to happen today, but this was a big time outbreak in 2011 during a record-breaking month of April, the most active month for tornadoes in recorded history in the U.S. While this tornado here happened during the morning hours, I do expect the tornado threat later on today to be more of a nighttime event. It looks like an evening, maybe late afternoon into the evening, and possibly an overnight potential tornado threat. I think it's a relatively small window in space and time when that strong tornado threat might happen, but the Storm Prediction Center has continued to upgrade those tornado probabilities up to a 10% hatch area across portions of eastern Louisiana, southeastern Arkansas, and a large swath of Mississippi. I split that area into two different modes of tornado potential. I expect a pretty significant tornado potential developing by this late afternoon by about 3 or 4 p.m. across eastern Arkansas, almost all the way up to the Little Rock area, but I do think that storms and a lot of precipitation is likely going to keep most of that instability just off to the southeast of Little Rock. The wind shear is actually most favorable across this zone off to the north, across eastern Arkansas, almost all the way up to the Memphis area and portions of northwestern Mississippi. This secondary area, this is going to be a mode of renegade supercells that are already developing over the open Gulf of Mexico. This cluster of storms is going to thrive off greater instability, greater moisture across southeast Louisiana, central Louisiana, and portions of southwestern Mississippi. This is also going to be a later mode, a little closer to sunset and maybe an hour or two after sunset, and that could even impact portions of the Jackson area by late afternoon near the I-20 corridor from Jackson all the way to Vicksburg toward Monroe. I expect these storms to develop by about 4 or 5 p.m. and then really mature across central Louisiana. So I see two different modes of severe weather developing. This one in Arkansas is going to be closer to the triple point. You're going to have a low pressure center that's going to move through central Arkansas right along the southern periphery of some heavy rain. There are flash flood warnings so far this morning just to the west of Little Rock. Along the southern periphery of that rain blob, there's a differential heating boundary or a warm frontal zone that's going to set up, and that's going to lift north to the east of that surface low, and then off to the south of that you're going to have a cold front or a Pacific front that's marching off to the east, and I expect that to also be the focus for supercell and squall line development, and that includes the warm frontal zone just to the northeast of that surface low. You can see that the surface dew points are into the upper 60s already, mid to upper 60s, so very moist environment, and that's going to be across southeastern Arkansas, northern Louisiana, possibly into portions of northwestern Mississippi as well. And you can also see that it's red, that mesoscale discussion, and that means that a tornado watch is going to be expected relatively soon. This is the radar right now, and it shows you that complex of storms that has triggered these flash flood warnings to the west of Conway, including the quartz digging locations here right around Hot Springs. If you're out there digging for quartz points, watch out for any debris plugs that could be moving through the area. The green, those are the flash flood warnings all the way down through the Mena area just to the north of Idabel. It's possible that there could be surface-based storms that first develop down near the Arklatex and then are going to move right along this differential heating boundary, right along the southern periphery of that complex of storms. You look off to the south and there's another mesoscale discussion that includes southern Louisiana. That includes Baton Rouge, New Orleans as well. And we're starting to get those bubblers. This is with a second mode that I was just talking about, that I just identified. This is with a little bit of a jet streak that's coming in from the south. And this is going to trigger the development of a cluster of renegade supercells that will develop over southeastern Louisiana. They're going to move off to the northeast, and eventually by later on this evening, this zone from Natchez up to Jackson, possibly the eastern section here of Louisiana too, including Monroe, Gina, Alexandria. I expect clusters of supercells to develop from southeastern Louisiana and then move up towards southwestern Mississippi, and they could have a tornado threat as well. So now I want to talk a little bit about the upper levels. The upper levels are where all of this starts, And there you can see that upper level storm system. It's a very potent upper level storm system that's lifting up toward the Great Lakes. And this thing reaches peak amplitude just before ejection. And you know that it's ejecting because a lot of the flow is located on the east side of the trough. That means that it's reached its greatest amplitude, digging almost down to the Rio Grande River, almost down to northern Mexico, and then it ejects up toward the Great Lakes. Anytime you get these ejecting storm systems that couple with the heating max of the day, that's usually going to be a pretty significant tornado outbreak. It's almost like a soccer player coming in to kick a soccer ball. The kick is basically the ejecting trough, and when it gains that negative tilt, see how it initially has a neutral tilt? The trough axis is located completely vertical, and then it gets a negative axis just as it's ejecting up toward the Great Lakes. Once it develops that negative tilt right there, the negative trough axis, the negative tilt, we call that with the trough, that means it is ejecting and lifting up toward the Great Lakes, and then it drags those favorable kinematics across the warm sector. This is the 850 winds. This is the wind about 1 kilometer above the ground. This is what creates the low-level wind shear that makes tornadoes thrive. And anywhere where you see that yellow right there, that's a strong low-level jet stream. But where it coincides with heat and moisture at the surface, that's when you get the greatest tornado potential. When those storms are able to drill down to the surface, that's called a surface-based storm. And then it's this strong southerly wind about 1 kilometer above the ground that causes that mesocyclone to tighten at the low levels, and that's when you'll get a tornado. But it's this moisture right here in the Gulf of Mexico, the purple monster down there, that's that deep moisture that I'm talking about. Those dew points that are in the 70s, that's because we've had a semi-permanent subtropical high off the southeastern U.S. There's your high pressure right off Florida, and you get these southerly winds on the western edge of that high pressure, and that will maintain this deep moisture. There might even be too much moisture to develop a big-time tornado threat today. We've seen this a lot with these wintertime setups. When you just get the Gulf of Mexico cooking like this, you get so many renegade storms, so many beans, tightly packed prefrontal confluence lines, all the storms competing against each other, competing for that surrounding heat and moisture, that a lot of times they won't go as big. And then the biggest outbreak that happened, you had the low 60s dew points into central and southern Alabama. That was when the Selma, Alabama tornado happened. You had a lot of dry air coming over top that moisture, a lot of cold air aloft as well. But you also had a very favorable trough ejection for that day. Today, I think we've got a favorably timed trough. We've got big moisture, so it should lead to a pretty significant tornado potential across eastern Arkansas, central and northern Louisiana, and a large swath of Mississippi. And we're going to break it down in detail coming up. But this is one of the latest HRRR models showing a very messy convective evolution later on today. In general, the wind shear and the thermodynamics are in place over a large area. Any of these areas where you see convection, if there's going to be a supercell storm that can sustain itself and become a surface-based storm, then it's likely going to have the potential of producing a tornado. Two different modes that come out. You've got this mode up here into eastern Arkansas. That one's going to develop near that ejecting triple point or the surface low, and that's going to move right along the southern periphery of that differential heating boundary, right along the southern periphery of that complex of storms. You might get an isolated tornado or two even this afternoon if you could get any surface-based storms to develop along that boundary. And then you've also got this cluster of renegades that comes out of southeastern Louisiana, moving up towards southwestern Mississippi. Look at all those renegades and bubblers that move up toward Natchez, eventually up toward Jackson as well, and eventually the squall line even catches up to those bubblers, and then you just get one dominant squall line with circulations embedded within it. This line is going to die out before it reaches the Alabama border. It's going to outrun the instability by about 10 or 11 p.m. These storms are going to start to outrun the instability as they approach the I-55 corridor. This is the surface-based instability here that I am showing you. And watch how that warm front lifts north. Right now, it's located near the Arkansas-Louisiana border. Boom! Look at that rocket all the way up to the north. You've also got some storms that are developing across eastern Arkansas. And it's those storms that I think are going to have some pretty significant tornado potential, riding right along that differential heating boundary or effective warm front. You're basically going to have a surface low that moves through central Arkansas, and to the east of that surface low, you're going to have a warm front that is going to lift off to the north. And any storms that are going to be able to develop along that warm frontal zone will have a chance of producing an isolated tornado or two. This is where the strongest wind shear is going to be located by about 4, 5, 6 p.m. this evening. Down here, you've got bubblers that are going to be coming out of eastern Louisiana, moving into southwestern Mississippi, including the Jackson, Vicksburg, Natchez area. Down here, the wind shear initially is going to be relatively marginal, about 150 to 200, 0 to 1 kilometer storm relative helicity. That's a bit more marginal for tornadoes, but once you get toward about 8 p.m., the wind shear suddenly kicks into gear. The low-level wind shear ramps up, and then you're going to have a threat of a strong tornado or two that could develop if those storms can be to hold on to their surface-based characteristics into the evening by about 7, 8, 9 p.m. So you can see that map right there on your meso-analysis. Watch what happens when I step forward. Boom! It ejects off to the northeast. Your trend is your friend when you're analyzing low-level shear like this. And notice how initially, right now, it's located near the Arkansas-Louisiana border. The strongest wind shear lifts up just to the east of Little Rock. You've got about 300 low-level storm relative helicity, and it's knocking on the back door of Memphis as you go through about 4 or 5 p.m. later on this evening. And you also have some surface-based storms that are moving right along that environment, just to the southeast of the Little Rock area. And if these storms are able to sustain themselves, they might have a chance of even producing a significant tornado just to the east of Little Rock, moving into this zone of very favorable wind shear. This is the first sounding up near just to the east of Little Rock, and you want to analyze what the environment's going to look like before these storms move into it so that you can better understand storm behavior. Here's your hodograph just above my head. This is your skew T, or your sounding. That shows you the temperature and moisture profile with height. You also have your wind field right next to it. And the hodograph is a way to plot your wind shear. You're basically looking down at the atmosphere, and you can see how the atmosphere changes. The wind fields change as you go up with height. Basically, you're looking down at the atmosphere and you plot your wind as a vector. Your surface wind, about 15 knots out of the due south. And each of these rings represent increase in wind velocity, 20, 30, 40, 50 knots. So wind can be plotted as a vector, which has direction and speed. Your 1 kilometer wind south-southwest at about 40 knots. Your surface wind due south at about 15 knots. That creates about 25 knots of bulk shear between the 0 to 1 kilometer layer. Here is the hodograph right there. And this is the one across eastern Arkansas. Does look supportive of a tornado. And it's possible that that tornado could even be strong, especially if a supercell is able to hold on until you get a little bit closer to sunset, and then that 1 kilometer wind that is out of the due south, south-southwest at 40 knots. If it can increase up to about 50 knots, you might even, or even 60, then you'd have an even greater shot at a tornado. And that tornado could be potentially violent as well. You do have this little dip right here between about 3, 4, and 5 kilometers. There could be a little bit of a negative contribution of the storm relative helicity by that. That really has been determined to be more irrelevant, especially if you have a long enough shear vector in the 0 to 1 kilometer sense. If you can get that shear vector greater than about 30 knots, then the strong tornado potential is even more significant. But it's borderline right here, but the hodograph overall is shaped properly that you certainly could get a strong tornado or two. And this middle and upper atmospheric wind is strong enough to ventilate the updraft, basically pull all the mass, the rain and the hail out of the top of the mesocyclone so that it can pull in plenty of inflow into the storm. So this is at about 6 p.m. right there. And one thing I'm noticing down in the southern mode is you do have a more prominent elevated mix layer. That's a dry slot. So where you see that green line getting separated from the temperature line a little bit more, that's an area of dryness in the middle atmosphere. That creates breaks in the clouds so that you get more surface heating. That also creates steeper lapse rates, and you get a little bit more cooling aloft over top that heat and moisture at the surface. Usually when you get a dry slot like that in the central and eastern U.S., it means that there's probably going to be a pretty significant severe weather event. You're bringing aspects of the Great Plains into the eastern U.S. where you have the deeper moisture, and anytime you get those elevated mix layers in the eastern U.S., it usually spells problems. Also, look how your shear vector initially is about 30 knots. So at 0Z, it just becomes supportive of a tornado or two. It does have this little loop up there in the middle atmosphere, which is really basically irrelevant. I'm seeing that shear vector of about 25 to 30 knots down there. And watch what happens if you go just a little bit later on, toward 8 p.m. We're going to go from 6 p.m. to 8 p.m. and watch what happens to that hodograph curve. Watch it right there. Boom, it gets even bigger. Your 1 kilometer wind goes up to 50 knots. So there definitely is a window in southwestern Mississippi when that 1 kilometer wind noses all the way up to 50 knots. When that happens, your low-level jet is really cranking just above the ground, 1 kilometer above ground level. Your surface wind even weakens a little bit down to 10 knots, so that elongates your 0 to 1 kilometer shear vector. This thing is exceeding 30 knots by 2Z, or at about 8 o'clock. And notice how your loop right there, that weird loop of negative helicity, gets even smaller between about the 4, 5, and 6 kilometer layer. Not as much ventilation aloft with the updrafts, so you're probably not going to have as much of a clean supercell out there. Probably more of an HP supercell mode. But boy, that looks quite favorable down across portions of southwestern Mississippi. And here it is. You can see it visually on the HRRR looped energy helicity index. That shows you where the low-level wind shear coincides with surface-based instability most favorably. Here's your initial mode across eastern Arkansas and into portions of northwestern Mississippi. That actually has the best wind shear at about 4, 5, 6 p.m. today. Eastern Arkansas, and it noses all the way up to Memphis. Western Kentucky, you're largely out of that tornado threat, just a little bit too far north of the instability. But then we get that second mode that comes out of eastern Louisiana and into southwestern Mississippi. That one's associated with greater instability, and initially the wind shear isn't as conducive for tornadoes until you get to about 7 p.m. 6, 7, 8 p.m. across southwestern Mississippi is a narrow window where the environment really comes together for a strong to potentially violent tornado. That includes Vicksburg down to Natchez, even Yazoo City, near Jackson, just to the west of Jackson. Watch out for that zone. And it is possible that it could even push all the way east to areas like Meridian, Laurel, and Hattiesburg. But I think that Alabama border, that's going to be the easternmost progression that this line is going to be able to go, because it's going to outrun the instability when it arrives into southern Alabama, and the tornado threat is then going to subside. So you got the most favorable conditions across eastern Arkansas, 4, 5, 6 p.m. And then again this evening, eastern Louisiana moving into southwestern Mississippi later on today. That's a breakdown of the tornado threat and the science associated with it. You've also seen my target areas. These are my 2 target areas where I think that the tornado threat is going to be greatest today, and including in between them. I know that there's a little gap in between those 2 target areas as well, but you could basically connect these there. But you got this environment up into eastern Arkansas. That wind shear ejects, and then you've got this environment from central Louisiana to southwestern Mississippi. That one's a little bit later, 6, 7, 8 p.m., maybe as late as 10 p.m. or so, but I also think that there's a threat of a strong to potentially violent tornado down there as well. So thank you, everybody, for tuning into this weather report. If you know anybody that lives in those areas, please share this report. And it's very important to stay tuned to those severe weather watches and warnings across this very large warm sector in the Mid-South. Thank you, everybody, and never stop chasing.